This is just supposed to be a overview, bird's eye view of everything you kind of need to know coming into probability, or by the end of this unit, which is called probability. So this has to heavily relies on your knowledge of chapter 3, which is set theory, chapter 4, which is the counting methods, right? Counting review. So this part right here is just to refresh yourselves on counting in particular. So notice when there's binary examples, so whether, right, boy or girl, like if a family has, 4 or 5 kids, how many ways or how many instances can you think of having exactly 2 boys in it? Or it could say at least 2 boys, or at least 3 girls, what have you. The best idea here would be to come up with a tree diagram, right? So boy, girl. So as many kids as we're talking about, that is as many ways as you expand this tree diagram. Same with tails or heads if you're flipping a coin. True or false, like if a question mentions that there's a quiz and it has 5 true or false questions, right? And they're saying like how many ways can you answer where you have, at least 2 true answers. And obviously that varies, right? There's 5 questions, so there could be the first one and the last one could be true, right? 1, 2, 3, 4, 5. The first one and the last one could be true. The first one and the second last one. So there's a lot of options to consider. So it's best to do a tree diagram for this. When you go into a maze and you have to go left or right, that is also binary. So all of these are classic for tree diagrams, and I'll show you a tree diagram shortly. So why don't we actually go there right away? So it's a little messy, I know, but this is the one category that I think is very important to have an example for, or to understand what to do. And unfortunately, there's not just one size fits all on these ones. But let's say a family has 3 children. How many outcomes involve exactly 3 girls? If it says exactly or just involve 3 girls, not at least, then it would be, right, 1 out of 2 chance for the first one, 1 out of 2 chance for the second one, 1 out of 2 for the third one. You multiply the tops and the bottoms, and then you get 1 over 8. However, if it says how many outcomes involve at least 1 girl, then it gets a bit more complicated with the at least or at most, right? If it's at least, you want 1 or more. If you consider 3 children, right, you want 1, 2, or 3 girls. So the best thing is to just lay out your tree diagram. It doesn't take that long. And then you get the fact that at least 1 girl will be 7 outcomes. Now, some of you might remember when you have the word at least 1, you could have used the property that out of the 8 outcomes possible, and we know there's 8 because 2 times 2 times 2, right? Like there's 2 options for every event. You could just subtract one of them, the case where all of them are boys, so there's no girls in that scenario. So you have 7 out of 8 still if it's a probability. If it just said how many outcomes, it would be 7. If it says what's the probability of that happening, it's 7 out of 8. So here's my other option where you go total minus 1 over 8, so that's 7 over 8. What about at most 1 girl? At most 1 girl. So no more than 1, basically. So you want all the outcomes where you have 0 girls or just 1. So I already answered that this is 4. Okay, so there'd be 0, there's 1 there, 1 there, 1 there. Okay, so that's already, this is 4 right there. This one we wouldn't count because that's 2 girls. So 1, 2, 3, 4, right? And all the other ones have more than 1, so we wouldn't be counting that. So you just count your instances where you have at most, so 0 or 1 in this case. Okay, 0 or 1. Probability of no girls, if that's what they asked for. Well, obviously in this case it's basically the same as all girls. because, right, 1 out of 2, it's not, so it's 1 out of 8 is the total possible outcomes. And this can actually be translated to questions where you have to go left or right in a maze. Those are your only options, or where you have to answer true or false, right? Now, what if this question said the first kid was a boy, for sure? Then technically, this first branch here, like the one that goes towards the girl here, that's all ruled out, right? If the first one is a boy, then that's fixed. And then basically, so that's fixed. So then you would basically just be down to 4 outcomes, 4 other outcomes. All of them have the first one being a boy, right? That's already fixed. So you have to be careful what the specific example is talking about, okay? So that would be, I'm going to close this chapter with, this is the binary situation where I strongly encourage you to use tree diagrams.